Okay, so today I will go through two a bit bigger projects, user interface applications, and how to kind of go about creating a user interface for them as well. So the first one is related to weather. So the idea is that I can show you so this is the web page from SMHI. And they have public APIs here where you can download data. So the idea is to create a Python class that downloads data from one of these services. And to do that, I usually always kind of implement most of my stuff in classes so I can reuse them later. So we're going to create a class SMHI, where really not much thought in that, but we need some imports for that. So the output from this service is actually JSON. So we were going to use the JSON library in Python to be able to get the data from the web service. We are going to use a module called requests, which is a module that can open a URL on the web and download, get a response from that web page and process it. We are going to use NumPy, matplotlib to kind of display things. And there are some other things here to plot dates. It's kind of technical details here, but we will use MATLAB just to kind of test that we get the data down. So the interface here is declared as SMHI class. So what it does, so the data actually is a forecast from SMHI. So you can query it for longitude and latitude and then get the forecast for that area. So in our constructor, we are going to put default values here for the longitude and latitude. So you can change that if you create a new instance of this class. I will also add some attributes here that so the user of this class doesn't have to know where this URL, where this service is located. So it's built in here. So we will store the URL in a string variable here. So open data download met fsct smhi.se. The API is located in a directory structure underneath this URL. And I create this API template here. And you can see I have these placeholders here for things that we need to fill in here. So, for example, there is a version here, 2, that goes into this placeholder here. There's a category here, PMP3G, which goes into there. So we create a template string that we will update. And here you can see longitude and latitude as well. And we add those as class attributes here. Then finally, we are going to, by default, request the data here. So I call a request forecast function here that is defined here below. So what that does is, first we need to assemble our API string. And we need to do that every time we do request because the user can have changed some of the categories here or versions or something here. So we assemble that using the format string here and just input the different values here that is going into the string. Then we are going to get the string response from the web. So here we add them together here. So self URL plus the API string. So that is the actual URL we are going to open. And we are going to open with a get command here. So this is the web command to get the data over the web. And that will download into a string, SMHI info. And then that is formatted as a JSON. So we can then load that using the loads function in JSON. So loads is a method in JSON that converts a string into a JSON structure. So it parses this string here and inputs it here and converts it into a dictionary with all the data we need. So we can actually just see how it looks here. So this is the print out SMHI info. And then just, I have the test program here to test this out here. So we will just do comment out everything here for the moment. So if we run this code now, okay, we should have printed out response.txt. So this SMH info is actually an object that is contains more properties. So we put text here, then we get the actual response text that is returned back. So here you can see this is the output from the web page that we have, and you can see it's in JSON. So we need to convert that into something we can parse in Python, and we can convert it into a dictionary using the JSON loads. And if we print out this one here, it's a bit difficult to see here now, but the same structure again, but now it's printed as a Python dictionary. So now we have a dictionary which you can query, which is much easier than parsing a lot of text strings. So the next step here is to we need to be able to extract what parameters there is in this forecast. So the forecast consists of parameters with date information. And the first thing is to be able to query this data structure. We need to get the names out of the series. So we loop over the forecast here, the time series here. And in the time series, there is a parameters key. And then we parse over the parameters, and we just add those together and return a dictionary of all the names. So the first thing we query is the parameters. And we can do print params here, just to see what we get out here. So here you can see the parameters and also the unit of the parameter. So SPP, pcat, category, p-mean. There is also temperature and humidity. So now we have that information. We can extract. So for example, if we want to extract the temperature, we can do. We have some other functions here as well. So parameter values will return the parameters, the dates and values of the specific parameter. So what we do here is we create two empty lists, and we do the same thing here. We go into the forecast time series, params in the parameters. We loop over. If we find a parameter name here, we just append the values to the list. It's perhaps not the most optimal things to do, but we need to kind of dig into that. And then we just return the date times and values. This. So we get date times. We run this here. We can see here that we get something that resembles temperatures, and we also get the dates of each measurement or in the time series. So just to kind of check that this works, we can plot the data here. And to get the dates right, I do some advanced matplotlib stuff here just to kind of display the dates correct. Otherwise, you get one date per parameter, and it kind of just becomes a big black thing with labels. So here I only display the date every 8 value. So this is the diagram we get out. So now we have went to a website, requested the data, we parsed it, created a JSON structure, and then we dig into that JSON structure to be able to get the data out. So requests module is quite powerful. So in this way, we have a really simple way of, this is basically what you have to do. You create an SNMHI object, and then you can extract the data from that. You can also put in latitude and longitude here if you want, and specify exact position here. But if you don't do that, it uses the default values here. So
about the names of the values
here,
names of tag series.
So if you look at so in the data structure there is a time series, you can say a list of time series, and then so we loop over the time series here and just query what is the parameters inside. So this is, perhaps we can just print one of them here. It does. There's a lot of data here. Okay, we do like, we take the first time series here, so just 0. So I mean, if you need the documentation, this is on the SNMHI homepage. So that's where I went in to look at the data here. But let's see if we can get it more. So this is one single time series. So you can see that the time series is a list of dictionaries, and there is the first one is valid time, and then you have parameters here, and then you can extract the. So what I do is just loop over all the time series in the structure, and get out the parameters here. And then I loop over the parameter and get the name here to get out the name of that parameter. So just to kind of check what parameters there are. And then in the parameter values here, I go into loop over the time series again. And then I check if parameter is name, then I just go to the values section of that time series and add those to my lists.
Basically, time series is a nested list of
yes.
and basically each of them have one of timestamp and then all the values.
Yes.
Okay.
So the next step here, now we have just a test program here. The idea here is to make a user interface of this, and to be able to select the time series and some query the parameters here. So I've created what you do then is you create a, see if I can change my I don't do it now. designer. So I type designer here, and then there is a file weather app UI. Scalar is a bit wrong, but I have a parameter here, longitude, latitude, and then a refresh button. And I named this one here parameter, a combo. So param combo, that is the control that will be in the Python. I have longitude edit, I have lat edit, and I have a refresh button here. So that is my user interface. Then I go back to here. And now I create my weather app here. So I will use so Qt, so as before, so Qt Py widgets and all the things I need. I will use an image here. I will use a core, some stuff from the core, and then I will use UIC for importing the actual user interface file. I have a matplotlib. Here are some stuff to enable us to embed our matplotlib window inside our user interface. So figure canvas, that is a control, like a button you can embed. Navigation toolbar is the control that controls the matplotlib user interface. So basically, these are two extra controls that we will add to our user interface. We need matplotlib, of course, NumPy, and we import SMHI. So notice now we have a class or module that is completely independent of the user interface and separate. So we just import it here in our user interface. It's available. And also here is a good thing when you want to install your application somewhere at some other location that is the default. You can actually query the system here. So the argument, just the parameters that is called when you start an application, you can query those using the sysargv list. And the first argument is always the executable path itself. So here I can extract where is my application located, and the app tier here will contain the directory of my application where my main Python file is. So that is I use this construct here to make sure that I load the UI file from the same location. So load UI and then weather app UI. Then I create a SMHI object here because we need that and make sure that it's attached or owned by the user interface. I have a attribute current parameter, which is the current parameter that is going to be displayed. We create our figure control from the matplotlib window that we will add to the user interface. I create a canvas, I create a toolbar, and then I add those to the window here. Then we also have our param combo here. So when the user selects from the combo box, we will connect a signal called current text changed to our own method on text changed. There we will update the SMHI object and query parameter and values for a different parameter. We will also do refresh button here to refresh the display. So request forecast. So it's here we have, and then we have update controls, and we have a plot here. So that we do that initially here when we start. So request forecast is basically we self-params, we query the parameters from SMHI object, we query the date, times, and values from the HMI object again, and we store them as attribute in our object. So self-param, self-date, time, self-values. And then we have what we call update controls. So here we clear the combo and we loop over the params that we have in our params dictionary and add those to the combo box. So the user can select from something. I don't know why we do that, but it could be interesting. Then we set text of the latitude and longitude. we convert those into strings here and add those to the text boxes. And then we plot. And here we basically do the same thing we did before, but for the user interface. And here you can see here on refresh, so when the user presses refresh, it will update the model. So we will take the latitude and longitude and set those in our SMHI object. We will request the forecast again and do the plot. On text change, sorry? So on refresh, that is when the user presses the button. And that calls refresh. So I just, so I don't have to, because I need to do this for several things. So I put the refresh into a separate routine because I also need to do that in the on text changed refresh.
When you scroll refresh.
I could have called that, yes. Do you mean here? Yes.
Why not put the concept on refresh? Why do you need this? Yes.
Because yeah. Could perhaps. The difference is that you on text will current param will be set as well from the text coming in. And then you have to do update model, request forecast, and plot.
Yeah, no, I mean, I see that the thing that I don't see is why you have only purposes to call my
You mean which one, on refresh or? Yeah, because that because on refresh, that is the button connected to the button event. I could have assigned refresh directly to the button event as well. What? Because I want to know, I want to have a separation to know which methods are called from the button, and it could be that I need to do more things with the button. But in this case, it's only one line. Then you could do it directly. But it could it's a good idea to collect all the event methods, so that you know that these are called from the user interface, and then you connect to your own functions from that, because otherwise you don't know, is that call somewhere connected to a signal? Here you know these are signal connected methods. So I also prefix them with on, just to know that this is an event. On, do something. Then we have a main routine here that starts out the application. And the first part here is just for when you have a Mac or a machine with high resolution screens, it will enable that scaling to be correct. Otherwise, the user interface looks strange or too small. And then I just create my weather window, I show it, and I run it here. So let's see if we can get it to work. Yeah, it's a bit odd here because I scaled my screen because of the projector here before. But this is the toolbar control, and this is the matplotlib figure canvas that you insert. So basically now you can create your own application that uses matplotlib. And I can go in here and select the temperature, and now it's refreshing the display again. I can change the latitude and longitude here, but I don't know. Let's see. Didn't change. Okay. Yeah. So that is the idea, that you create one module class, that is in this case the SMHI class, and then in the weather app you import the module here and use that and create the user int for that. And here I have the update controls to update the controls from the model and the other settings. And update model takes the values in the user interface and updates the model. So you have this kind of two-way communication. So that was a smaller application. So I have a bit more complicated one as well. Both of them are in your in this GitHub repository you can run yourself. So the second example I wanted to show here today, let's see if I can just close them. It's actually a complete engineering application for continuous beams. So beams that are connected together and with a load that loads in each part here. So just show you how it looks when it's run. Let's see if we can see if I change the scale. So this is the application. It has a menu and it has a toolbar. And then this is a beam. So it's something that is loaded and there is a support and it's fixed in the wall here. So this will give you the deformation of the beam, the section forces and the moments in the beam. So I also used the matplotlib here. So when I started to implement this, I created first a model class that implemented the computational model. In this case, I use the modules that we have developed at Structural Mechanics called CalFem, which contains all the computational functions we need. We need also NumPy. We will use JSON as the file format for this. And here is the B model. I have some constants here just to define if a support is fixed in the Y direction, fixed in X and Y direction, and completely fixed. So instead of having numbers 1, 2, 3, I just have them as fixed X, Y, and name constants here. Init calls new, and new here is to create a new model from scratch. So if the user presses the new button in the user interface, the model will be initialized. I store the length of the sections here in 2 parts here. So first one, second one here. Segments here is the computational parts that divide up each segment here. So I have 10 and 20. I have loads 0, 0, so I don't have any loads from the beginning. Support is X, Y in the first support, Y in the second support, and fixed in the third support. And then I have some other attributes here as well for the model. I have a method called solve that solves the problem. So I set up some parameters here. It's just, and then it adds those properties to each segment. And then it does some computation. It creates some matrices and sets up the system, loops over the beams. So I have loops over the lengths, segments, loads, properties here. So this is a nice way of looping over multiple parameters here. So I get L, N, Q, P, which I then use here to assemble the system matrix. And finally, I solve the system matrix here as well. And then I store results here in some variables. I compute the element forces and so on. So this is you don't have to know too much about it, but it will generate values which is stored in arrays for each of the segments of the beam. I have a method here for saving the model as a JSON file. So I create a dictionary, and then I store my different structures here. So the lengths list, the segment list, the loads list, the support list, the properties list. I store those in the dictionary here like this. I open a file for writing and just save it down to the file. And then to go the other way around, you do the opposite. So you open the file name and you create a dictionary and you load that from the file. And if everything goes right, I add the assign those from the read-in dictionary here, like that. And here it is. I always try to have a test example here for each module. So for the B model here, I load it like this, and then you can run it, and it should produce some. Yeah, didn't plot anything here, but let's see here. Oh, I even remove matplotlib here. Okay, we skip that for a moment. But this is the computational model. So now I need to create an application from this. And it's in multiple parts here. So what I did here is I created a class called drawView for modifying adding stuff to a matplotlib drawing here. So I implemented some drawing function, line, polygon, rectangle, to be able to draw the geometry. The diagram itself we can draw with normal things here, but I implemented some basic drawing functions here because it's so complicated to draw in matplotlib, so I made it easier. And then I created a beam view that takes a beam model and displays it on the screen. So it inherits from drawView, so you get access to those drawing functions. Initialization here, I have beam model, that is the model I want to view. The figure is where I want to draw. So this beam view takes as input beam model and a figure to draw on. And we store them inside our object. We set some empty attributes here, some scaling factors. We set up the plots, and we draw the diagrams here. So here we get the data from the model here, and then we create our diagrams here. And then we draw the geometry here. And here you can see here, we use the rect line functions from the drawView here. So if we run the program, the beam view is actually this middle part here. That is the beam view object that we have added to our main window. And the drawing functions is drawing this geometry on top here. Then I also have, in the main application, so you can see here we have a default file name we set to empty. That is just used to be able to, if the user hasn't saved the file, this is empty, we can check if it's saved or not. Support windows are additional dialogues that for editing the input. We start by creating a new model. And new model here, we'll just set up some default values for the initial beam. And we've also solved it, so we have a solution directly. Then we create the figure canvas, attach it to our user interface. We add the toolbar for the matplotlib window, create our beam view. And here you can see we attach the beam model and the figure into that one. And then we tell it to draw. We connect all the user interface to actions here. So we have exit, new, open, save as, segments actioned, and BC actions triggered. Connect them to our own events. And if we go through them here, you can see here where we do new, we create a new model, and then we ask beam view to draw, because now those are already configured to where they know where they should draw. On exit, we call self-close, which is a method on the window. And if you close that, the application will close as well. On open, we will create a user interface or standard dialog for selecting a file. And then if file name is not equal to empty here, we just do new, open from JSON. So here you can see we use the model methods here. So the model itself knows how to load itself from a JSON file, and we ask it to solve, and then we call beam view to draw the updated model. Same thing here, the other way around. We ask for a save file name, and then we do beam model save as JSON here. So we use the same implemented function we have our beam model to do that. So we cannot try to don't have too much code in the user interface. On segments here, we create the windows for editing the segments, for editing the supports. So we have actually two UI user interfaces more. We have beam segments. So if we go designer, beam. So this is a user interface here for editing each of the segment properties. So you have a geometry, you have a load, we have material. So this is a tabbed user interface here, and you can see the springs here to make it scalable. And here you can add and remove segments from the beam as well. And we have the beam supports. No. We should open Python files that supports UI like that. Very similar dialog here. It's more simple because the only properties we can set on the supports is if it should be XY fixed in XY, and only fixed in Y direction. And those, if you look at the beam segments Python here, you can see it does mostly the same things here. It loads the user interface from here. It takes input here, the beam model and the beam view. So the reason we provide a beam view is to be able, if you modify something here, the beam segments window can also ask the beam view to redraw. And we store those as attributes in our class. And then you connect all your user interface stuff in that. And you have an update list, update controls, update model here again. You have on current, row changed, and methods for handling the user interface for the different, those dialogues. So if we run the app again, show you those. So if we go to here, you can see this user interface here. It looks nicer if my screen hasn't scaled strangely here. You have the tabs you can change here, and the segments here. I can also add a segment here. Okay, I couldn't. Okay, you should have be able to do that, but we can change here, for example, segment length here to 3 meters. You can see here it updated here and automatically recalculates. So 4. We can change the load here to minus 2000. You can see it changes automatically here. So when I press update, it will call update view and so that it's redrawn directly here. Then I also have, if you are working with, if you want to have you want to have toolbars, you can create special files called QRC that are resource files that contain references to the icons you want to use here. So I have a dialog box here with a directory here with several icons for the toolbar, which is loaded. So if we do the designer here, It's so cramped here. I can't. Let me check this one here. Yeah, actually, here you can see the names here. So here you can choose a resource. You can create in this tool here. You can create the resource file and add your icons to it. But basically, it's a just a file with that contains these things here, and then you can compile that. I will show you documentation for that, and then you can compile that into a resource file that you can embed into your application. So in the Beam app here, we have the Beam resource, I think, somewhere. Yeah, here. So you import that, and that contains the images in Python code. So that you can look at those. Those are in the UI folder under cases. So there is a weather app and there is a Beam app, and you can look at those to see when you're going to implement the graph plotter, which is your assignment in Qt. So the idea is that you create application that you can enter an expression and where you can plot a function. So we will use Python can actually call itself to compute expressions internally. So that was what I wanted to go through today.